board. This rover is supposed to last for 2 years on the surface of Mars. It's into about its first month on Mars. And a heck of a lot more science, as I said, heck of a lot more cameras. It even has a laser. It can shoot rocks with a laser. That's cool. Can't get more cool than that. Shoot rocks with a laser. The laser creates a little plasma, and from looking at the plasma, you can get a sense of what that rock is made out of. And here's all the instruments on the end of the arm, all tucked up here, and that's getting deployed as we speak and operating on the surface of Mars right now. Got a weather station. It's got a radiation detector. Shoots neutrinos shoots radiation into the ground and looks at what's scatters back into the detector to find out if there's any hydrogen in the soil, which more than likely is captured in the form of water.
This is not solar powered?
This is not solar powered. This big old monster in the back end here, you can see here, is a spot for a radiation source. It's called a RTG, radioactive thermal generator. So the radiation source creates heat, and that heat you can create electricity. You know anything about, you can measure heat using a thermocouple. This device works in backwards. It uses the heat to create electricity. It also uses the waste heat and pumps that waste heat into the rover body itself to keep all of its electronics and its instruments at a nice constant temperature. So no solar panel. You don't see a solar panel here at all. This big thing on the back end is a radioactive heat generator that creates electricity.
But it will have an end.
Yeah, but the half-life is very long. I mean, so Viking used one of these, both Viking landers, and they lasted for 6 years. And shockingly, Opportunity has outlasted both Viking landers now. Spacecraft that go into deep space, Cassini, Galileo, the Voyager spacecraft that are heading outside of the solar system right now, all operate on this power source.